This video will demonstrate how one can make manual power measurements on the AM335X GP-EVM using shunt resistors. Power management is proving to be increasingly important in system-on-chip devices used for industrial automation and home automation. Power management enables users to design robust and reliable systems while making important decisions regarding power, performance, and thermal trade-offs. This training video will equip users with the tools needed to quickly measure power. With this basic understanding, users can start playing with the RTOS power measurement framework, including tools, hardware, and software examples available for power management and measurement. Our measurement demonstration hardware used in this video includes the following: AM335 GP-EVM. The standard AM335 GP-EVM was used for these tests, and a handheld multimeter. As shown in the table, AM335X GP-EVM has 20 unique power rails, including VDD MPU and VDD core. All of these rails can be measured independently. In this video, we will focus on manual measurement via shunt resistors using a handheld multimeter. The simplest way to implement power monitoring capabilities is to include low resistance, high precision shunt resistors in the power supply rails. By measuring the voltage drop across the resistor and the supply rail voltage, it is simple to calculate the power consumed by the measured rail. Typical values for these resistors can be found in the AM335X Evaluation Module Hardware User's Guide. It is important that the multimeter used has enough resolution and range to capture meaningful voltage readings. Ideally, your multimeter range should be in tenths of millivolts to single-digit millivolt range. Measurements can be made directly at the terminals of the shunt resistor. It may be convenient to use jumpers or test points placed close to the shunt resistors to monitor the voltage across the resistor. Let's measure the instantaneous power consumption in the MPU rail after power on using the RTOS pre-built image in an SD card. For this calculation, we need to measure bus and shunt voltage across VDD MPU. For processor SDK RTOS 4.0.0 release, the MPU bus voltage measured between J19 pin 5 and ground should be 1.1 volts, and the MPU shunt voltage measured across the 0.05 ohm resistor R46 should be around 6.5 millivolts. For more information, please see the schematic. Now, we simply plug in the numbers in the formula. Power is equal to voltage times current. Here, we'll use the bus voltage and shunt voltage divided by shunt resistance to get the current. That equals to 1.1 volts times 6.5 millivolts divided by 0.05 ohms equals 143 milliwatts. In our lab, we have used the concepts discussed in this video to automate the power measurement process. For this purpose, we used a Keithley multimeter with a multiplexer card capable of measuring 40 channels. This setup allows us to estimate power across 20 rails on AM335X GP-EVM within a few seconds. To recap, in this video, we saw how to measure MPU bus and shunt voltages and calculated MPU power for AM335 GP-EVM with the out-of-the-box RTOS pre-built image on an SD card. Thanks for watching. For more information, please see the references.